I'm Anil Kumar. Welcome to my series with Amy. We are taking some challenge questions from past test papers of Edexcel. Here is another excellent question. Now, this is based on the application of vectors. Here we have a boat whose position changes from A to B. We need to find the speed of the boat and the bearing angle. Now, here is a lesson with Amy where we are going to understand the solution of this particular question. Hi, Abby. How are you doing?
Hi, sir. Yeah, I'm very well, thank you. How are you?
Very good, very good. So, today, what do you want to do?
So at school we had a couple exams that we did, and some topics I found a little bit tricky. So I just wanted to go through some of them with you, if that's okay.
Sure, that's fine. That's fine. So, why don't you share with me? So, I'll just let you share the screen. Yeah, you can share with me, and then we'll work on those things.
I think it's that.
What? Okay, it's sharing.
Okay, cool. It's kind of like backwards, so I need to kind of go all the way down here and go from question 1 onwards.
Okay, that's fine.
All right. I think question 1 was fine. It was 2. So.
Okay, sure. Yeah.
So.
Yes. So, Can you read the question?
Yeah. So, a Coast Guard station monitors the movement of a small boat. At 10 o'clock, the boat is at point the vector vi minus 2j kilometers relative to O. At 12:45, the boat is at point minus 3i minus 5j kilometers relative to O. Okay. The motion of the boat is modeled as that of a particle moving in a straight line at a constant speed. Part A, calculate the bearing on which the boat is moving, giving your answer in degrees to 1 decimal place.
Correct. Right. And so bearing means from the north, correct? The angle from the north. That's what it means. So what you need to do is, first thing first, you have to kind of sketch. So when you try 4i minus 2j, so 4 on this side and minus 2j, let's say this is 1, 2, 3, 4, and minus 2j means the point is here, right? And then the second point is minus 3i minus 5j. So we say 1, 2, 3, and minus 5. So it'll be 1, 2, 3, 4, 5. So approximately here, correct? So let me just connect them with a line. So those 2 points which we have, so we can just connect them with a line. Just so these are the 2 points which we are talking about. Is that correct?
Yeah.
So at 10 a.m., the boat is at this position. So A is my first position, which is at 10 a.m. Is it okay? So 10 a.m.
Oh, right. Okay. Yeah.
So position B is at 12:45. Right? So these are the 2 positions. So the part A is calculate the bearing on which the boat is moving, giving your answer. So basically the bearing is the angle in which it is moving, right? Mm-hmm. So you need this direction. You need this direction. Okay? And then you have part B is calculate the speed of the boat, giving your answer in kilometers per hour. So these are your 2 parts. So basically you have to find the velocity. Right? Speed is the magnitude and bearing is the angle. So basically you need to find the velocity. Is it okay? So the velocity vector is something which you need to find. Correct?
Wait, so how come, sir, you know that it's moving in that direction?
Because at 10 a.m., it is at location A, which is 4i minus 2j. And at 12:45, that means after 2 hours and 45 minutes.
Oh, so it has to be that way. Okay.
Yes, it has to be that way, right?
Right.
So it is that the bit. So let's start with the distance speed, right? So let's find the speed magnitude. So you can find the magnitude of speed by, the coordinates of these 2 points, right? So distance formula will give you the speed. Is it okay?
Yeah.
Let's find the distance. So what is the distance between AB? Distance AB is how much? Square root of x2 minus x1 square, right? So the I components are the x1, x2. So minus 3 minus 4 plus the y components being -5 and minus of -2 will be +2 whole square. Is it clear?
Yeah.
So 7 square is 49 plus 5 plus what whole square did I write? 5 minus 5 plus 2 plus 2 plus 2. Yeah. So that means -39 square is 9, right? So you can use your calculator to find this distance, because we need to give this distance, feed to the board, giving your answer in kilometers per hour, right?
Yeah.
So 49 plus this is 58 square root. So you can find this answer, square root 58.
5√2. Oh, 58.
Yeah, you get what? 49 plus 9, right? So
7.615.
9 equals to square root. Answer equals to 58 square root, which is in decimals 7.6, right?
Yep.
Kilometers per hour. Is it clear to you? Sorry. No, this is only the distance. I'm sorry. This is only the distance. And the time taken is how much? 2 hours and 45 minutes. Find the time. Time is 12:45, right?
Wait, so are we doing part B?
We are doing part B first.
Oh, okay.
The distance and time, we will find speed first. Magnitude, and then we'll find the direction. Don't worry.
Oh, okay. Because you know how we've discussed this, like, you know, with usually the questions they give, they like you want to do it in order, part A and then part B, but sometimes you end up doing it like part C first, maybe.
Yeah,
so I was just checking with you. Okay.
Doesn't matter. So what I want you to understand is it doesn't really matter, right? If you want to find the angle, you have this particular triangle, correct? You can find the angle also. We can say this is my tan theta, right? Or any one angle, which is rise over run, right? So we can find the angle also. We'll do that. Don't worry.
Okay. Yeah.
Yeah, we are finding part B first.
Okay.
So the time taken is, so 12 point, when it is 45, it means what? 3/4, right?
3/4 of an hour. Yeah.
So 0.75, right? So convert that minutes into hours. So you could do 45 divided by 60. So when you do 45 divided by 60, you got 3/4, right? And
0.7.
Yeah, to that you add 2. So it is in hours, we have the answer, which is 2.75, right? So time is 2.75. Is that clear to you?
Yeah.
And therefore, we got the speed, which is change in distance over change in time. And the total is, you can say 7.61, whatever you got there, divided by 2.75, correct? And you have your answer.
$2.77.
Yeah, we will calculate the speed, giving the board your answer in. So maybe 7.7. Yes,
3.7. 3 significant figures.
2.7, 3 significant figures, 2.77, right?
Okay.
Kilometers per hour. Is that clear to you?
Yeah. I think I get so caught up in doing it in the order, because I think I remember in the exam when I did this question, I found the bearing part so hard, and then it has no relation to part B, but I just kind of flustered and then just moved on. So I lost the 6 marks because I couldn't do part A. But as you've seen, that you can do the part B, so I could have at least got half the marks. Yeah. I
know that. You know what? Because I've been teaching you for a long time now. I know exactly how you will feel when you see this question, and because you're asking me this question, that means you got stuck at part A, right? Yeah, I did. Yeah. And therefore, you didn't move forward. So I started with part B. First thing first, when you read a question, whatever is simpler for you, start from there. Oh. You have to do both parts, right? Yeah, that's smart. Yeah. So it doesn't matter which one comes first. Now, bearing angle is the angle from the north. Let me explain you what bearing angle is, right? So now we have this particular triangle, and in this triangle, we know the 2 points, correct? The points are 4i, and so difference in y is how much? So you've got 4 there, and you've got -5. So this is 1 unit, right? This is 1 unit. I mean, sorry.
3. Is it 3
7
units?
units. 7 units. 4 minus 3, 7 units, right? This distance 7 units. Change in x.
Oh, yeah.
And change in y is how much? 3 units, right?
3 units, yeah.
Correct. So I'm making it very simple for you. So the change in y is 3 units, as you can see from these figures, right? And change in x is 7 units. This angle is the theta angle. So what is tan theta equals to?
Opposite over adjacent. So
3 over 7?
3 over 7.
So
Yeah.
theta is tan inverse. Find it out.
Um, 0.404.
Okay. No, degrees.
Oh, I've been working at school in thingy.
I think they expect you in degrees, right?
Yeah, they do. Sorry, my bad.
Yeah.
23.19.
Okay.
So 23.2 degrees.
So this is the angle which you can see here, right? So we are asking you, what is the bearing angle? You get the idea? Bearing angle means, now this is that angle which you can see. Now let's look into the bearing angle. What is bearing angle? Bearing angle is the angle from the north. That means it is actually going in this direction. Do you see the direction it is going? No. So from the north, I mean, so I should say this is what you need, bearing angle. Bearing angle is from the north, so the direction is this. Do you see this angle?
Yeah.
That is the angle which you have to report. So how much is that? If this is theta, then as you can see from here, this angle is 90 minus 23.2, right?
Yeah. But can't we do 180 minus?
No, I'll tell
you. No.
Then you add 180 to it.
That makes no sense.
Right. Then you add 180. Or, yeah, that is better.
Yeah, so that's the method. Yeah.
90 minus 23.2 is how much?
Is 66.8.
Now, from here, 66.8 and then 180. Do you see that?
Plus 180, yeah.
Correct.
246.8.
That is your bearing angle.
Oh, okay.
You get the idea?
Yeah, I think, when I did it, I kind of stopped. I don't know. I think I just did the 66.8. I didn't add on the 180.
Okay. Other way you could do, let's do the alternate also. You could find this angle, correct?
Oh, yeah.
That means what angle you found is this angle, correct? Which will be 66.8.
Yeah.
And then add 180 to it. Is that clear to you?
Yeah.
So find this, do tan inverse of 7 over 3.
$66.8.
Add 180.
246.8.
So which method you found simpler? This simpler, right?
Yeah.
Correct. So when you look at the question, try to make a figure, then, if you're getting stuck at one part, see if you can do the other part first. At least you've done one part, right?
Yeah.
And you will get marks for that, correct? 3 marks. You got 3 marks, correct? Now, by the time you finish the second part, you will get an idea like how should I have done the first part.
Oh, right. Yeah, because I'm more engrossed in the question and I've already done a couple calculations.
If you look into this part, it is easy to, let's say phi is this angle, find this angle. It makes more sense because this angle with the vertical is same as that angle.
Correct? Yeah.
And we have to report angle from the north. So we'll add 180 to this and get our answer. All this is clear to you now, right?
Yes. Yeah, very.
Right. So I'll clear this. We're done question number 1. Can you please tell me the strategy adopted in answering question number 2?
So, when in the exam or what you just explained? Yeah,
in the exam, how will you approach?
Oh, okay. So when I come across it, first it's all about drawing a diagram.
Correct.
So do the axes and then plot the points. So you do 4 along the x-axis, -2 down, plot that as so at 10 o'clock. And then at 12:45, you've got -3, -5, and draw your triangle. So yeah, that's the first sketch. And because I know with vectors the distance formula, I've already got 2 coordinate points, so just basically sub them in and start by calculating the distance of AB.
Correct.
So yeah, square root that, and when we got our answer, we had our distance, but then our time was between 10 o'clock, sorry, and 12:45. But we have to make sure it's in hours because the units say kilometers per hour. And then when we find that time in hours, we just do speed equals distance over time, and then you get your speed of the boat in the correct units. Okay, and then after we calculated part B, we can easily do part A because we've got like all the calculations and we've got a triangle, our angle theta, and then use our values of 7 and 3, which is found by using those coordinate points, and find it. So because it's a bearing, we need to make sure it's from the north and clockwise. So then you find that theta value and then add 180.
Yeah. That gives you the angle from bearing. This is absolutely clear, right?
Yeah.
Correct. I hope you have understood the solution. However, we should summarize and see how we can do or answer this question very efficiently. Once again, the question is, a Coast Guard station O monitors the movement of small boats. At 10, the boat is at the point 4i minus 2j kilometer relative to O. At 12:45, the boat is at the point minus 3i minus 5j kilometer relative to O. The motion of the boat is modeled as that of a particle moving in the straight line at constant speed. Calculate the bearing on which the boat is moving, giving your answer in degrees to 1 decimal place. B. Calculate the speed of the boat, giving you answer in kilometers per hour. So the best way to solve this is definitely to sketch and understand the situation. So I'm going to make a very rough sketch here. So let us say this is our coordinate point, this is our coordinate plane, and point O is right at the origin. Right? So that's the point O for us at the origin. At 10, the boat is at the point 4i minus 2j. That means somewhere here, right? And at 12:45, the boat is at the point minus 3i minus 5j, so somewhere in quadrant 3. So let me connect these points, right? So let us say this is what we have. So the positions are, here we have the coordinate point, which is 4, let me write 4 comma minus 2, and in this position it is minus 3 comma minus 5. So we're taking I and j, so I is along the x-axis and j is along the y-axis. I and j are actually the unit vectors. So it is a good idea to only write x and y. You get the idea, right? So x and y. I and j are unit vectors, so I should write j as a unit vector here and I as a unit vector along the x-axis. I hope this concept is clear, right? So then we can use the coordinate plane and write down a point 4i minus 2j as shown here. Let me call this as the starting point. Let's say this is point A and this is a point B. We need to calculate the bearing on which the boat is moving, giving your answer in degrees to 1 decimal place. To find the bearing, let's understand what a bearing angle is. So remember, when we say a bearing angle, we are always measuring from north, clockwise. So bearing angle from north clockwise. That is what it is. So in this particular case, the bearing angle will be from north clockwise, means that is the bearing angle. Is that clear to you? So that is the bearing angle which we need to find. The shortest and the best way to do it is make a right triangle right there, right? So let me just extend this. We're using vectors. Okay. So when we make this right angle triangle, let's call this point as, let us say, C. In that case, what is A to C? So you can see that A to C is basically equal to what? We're talking about the magnitude of AC. It is difference in y values, correct? That is to say, it is equals to minus 2 minus of minus 5. And that is minus 2 plus 5, or you can see it is 3. Is that clear to you? Now what is BC? Magnitude of BC is basically change in x direction, right? So it is from 4 to minus 3. 4 minus minus 3, that gives you 4 plus 3, which is 7. So we have this particular triangle right there. Let me write down this as 7 units and AC as 3 units. You can see very clearly that angle right there at A is the angle, which is this small angle, which is 180 plus that angle will give us a bearing angle, correct? So let us find what tan of A is. So tan of angle A, which is ratio of opposite to adjacent, is basically BC over AC. And that is equal to 7 over 3. So that gives us angle A as equal to tan inverse of 7 over 3. We need to find this in degrees, so we should have our calculator in degrees, and we can have shift, we get the tan inverse. 7 divided by 3 gives you the angle, which is 66.8. So we get this angle as 66.8 degrees. Is that clear to you? Now bearing angle is what? So bearing angle will be 180 degrees plus the angle A, which is 66.8. Is that clear to you? So we'll add 180 to this, and we get 246.8 degrees. Do you see this 180 degrees? When you add 180 degrees to the angle A, which is the same as shown here, let's say at point D, we get the bearing angle. Do you see that part? How easy it was to use this particular triangle and figure it out. Correct? So that is how we are going to do this particular part. So bearing angle, first thing first, is this angle, which we have calculated by adding 180 to angle A. Now let's look into the second part, which is how do we calculate the speed. Speed is distance over time, correct? Now we know that we are moving from the point which was, let me write down the points here, 4 minus 2 to minus 3 minus 5, correct? So we are moving from this to this. That is what we are moving from. So the distance is basically square root of x2 minus x1 whole square plus y2 minus y1 whole square square root. And the time in this particular case is the difference, which is 12:45 minus 10 a.m. Is that clear to you? So we can calculate the speed as plugging in the values for, we also just calculated these differences. There were 4 and 3, right? So if you make this 7 and 3, correct? Well, you can again write and calculate, but I'll prefer to write now 7 square plus 3 square square root. Is that clear to you, right? So we can calculate this value 49 plus 9, which is what? 58 square root, correct? So that becomes the distance and speed. Let's divide this by, let me use another ink. Let's divide this by 12:45 to 10. That means 1 hour 45, 2 hours 45 minutes, correct? So we have 2 hours 45 minutes. So let's convert all of them into hours, correct? So that means 2 hours and 45 minutes is 3/4 of an hour, correct? So we'll divide square root of 58 by 2 hours, 3/4 of an hour, or 2.75 you can say, correct? Either way you could do it. And let's calculate. So we have square root of 58 divided by 2.75, and that gives you the answer as 2.769, which when rounded to one decimal place could give you 2.8, right? So as far as speed is concerned, they are not telling us to round to how many. Calculate the speed of the boat, giving your answer in kilometers per hour, right? So that is kilometers, and this is per hour. So we can say 2.77 or 2.8 kilometers per hour. Is that clear to you? So that is how easily we can actually solve this particular question. I hope these steps are absolutely clear. I hope that you understand how do we solve such questions in the examination. So the idea is, when we have vectors, we can locate them on the coordinate plane as 2 points. These 2 points, we can find the distance between them using the distance formula, and then dividing by the time itself, we get the speed. And the strategy which we use by forming a right angle triangle, as you see, makes it absolutely simple. Now in that right angle triangle, we measured the angle A using tan inverse of the two sides, added 180 and got the bearing angle. This is one of the best ways of finding the bearing angle. I hope you understand the solution and you enjoyed the video. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.